AI has recently become a huge part of our everyday lives, so I figured it was time I actually understood how some of it works. In this video, I decided to learn RAG because I think it's a crucial pillar in modern AI. This isn't a tutorial, it's a breakdown of what I learned, how I approached it, the problems I've ran into, and what I ended up building. The goal of this project is to build a chatbot where users can upload their own PDF files, allowing the AI to give more personalized and context-aware responses. So what is RAG? RAG stands for Retrieval-Augmented Generation, and it connects LLMs to external knowledge, making them more accurate, prevalent, and reputable by reducing hallucinations and providing up-to-date information. To understand this better, I read articles from both Google Cloud and AWS. Here's my understanding of RAG and how I plan to use it for this project. If a user wants a more personal experience, they can then upload a PDF of the content they desire. That PDF would then be extracted from its text into chunks and be sent straight to the LLM. In this case, I'm using OpenAI models. The model then converts the chunks into vectors, and those vectors are stored in a database. For this project, I'm using Pinecone, as it is considered as a dedicated vector database. Then finally, when the user asks a question, it then turns that question into a vector. It then asks Pinecone which chunks in the PDF mathematically is closest to this question. A hidden system prompt combines the chunk, instructing the model to answer the user based only on this context. After understanding what RAG does, I wanted to dig deeper into how RAG actually works under the hood. I wasn't planning to implement it from scratch in this project, but I still felt it was important to understand the process. If you're interested in learning more, I'd recommend checking out this article from Geeks for Geeks. First, I needed to get my API keys for both OpenAI and Pinecone. I signed up for both and got my API keys pretty easily. For OpenAI though, you do need to buy credits to use their model, and while I'm broke, I'm not that broke, so I put in $5. Alright, let's start with the backend. I decided to use Python since it's the most common language for AI and machine learning, and honestly, I just like Python. Next, I had to figure out what API design made the most sense. I went with FastAPI since it's widely regarded as one of the best choices for AI and ML applications. Then came the bigger problem, extracting content from PDFs, turning that content into vectors, and storing it into Pinecone. This is where LangChain came in. So now let's walk through what this backend code is actually doing. I'm using FastAPI to spin up a simple backend whose only job is to take in a PDF, process it, and store it as vectors in Pinecone. At the top, I import everything I need. FastAPI handles the API, LangChain handles the PDF loading, text splitting, embeddings, and Pinecone integration, and .env keeps my API keys out of the code. I also added Core's middleware, so my frontend, which is running on localhost 3000, can actually talk to the backend without the browser blocking it. The main part is this ingest endpoint. It accepts a PDF file, saves it temporarily to disk, and then loads it using LangChain's PDF loader to extract the text. That text gets split into chunks using a recursive text splitter. I'm using a chunk size of 1000 with some overlap so context isn't lost between chunks, which is pretty important for RAG. Those chunks are then converted into embeddings using OpenAI's embedding model, and finally stored in a Pinecone index under a specific namespace. If everything works, I return a success response with the number of chunks created, and then I clean up by deleting the temporary file. And that's the entire ingestion pipeline. Upload a PDF, chunk it, embed it, and store it for retrieval. Now let's talk about how querying actually works. This is a post endpoint that takes in chat messages from the front end and uses them to generate a response with RAG. First, I pull the most recent user message and extract just the text content. The AI SDK can send messages in different formats, so I handle both cases to make sure I always end up with a clean input string. This also prevents crashes when the message isn't pure text. Once I have the user's query, I only generate embeddings if there's actually text there. That text gets embedded using OpenAI's embedding model, just like during ingestion. I then connect to Pinecone, grab the same index and namespace I used earlier, and run a similarity search using that embedding. I take the top few most relevant chunks and stitch them together into a single context block. After that, I convert the incoming chat messages into the format the model expects. This keeps the conversation history intact instead of just answering one-off questions. Finally, I stream a response from GPT-4 Turbo. I pass in a system prompt that tells the model to answer only using the retrieved context. This is what actually makes it RAG instead of just a normal chatbot. the response is streamed back to the UI in real time, so it feels fast and interactive. And that's the full loop. The user asks a question, relevant chunks get pulled from Pinecone, and the model responds based only on that information. Now let's look at the front end. This is the client-side React component built with Next.js. I'm using the AI SDK use chat hook to handle the chat logic and stream responses from my backend. At the top, I set up the chat connection so messages are sent to my API chat endpoint. The hook gives me the messages, the send function, and the current status, which is basically everything I need for the chat UI. I also keep some local state for file uploads, things like selected PDF, whether it's uploading, and the current input text. On the left side of the screen is the PDF upload section. When a file is selected and uploaded, it gets sent to my FastAPI backend ingest endpoint. That's what kicks off the entire ingestion pipeline we talked about earlier. On the right side is the chat interface. Messages are rendered differently depending on whether they're from the user or the assistant. And I added auto-scrolling so new messages always stay in view. When the user submits a question, I send it through the AI SDK, which streams the response back in real time. That response is coming from the RAG pipeline, meaning it's grounded in the PDF that was uploaded earlier. So at a high level, the flow is pretty simple. Upload a document on the left, ask questions on the right, and get answers that are actually based on your own data. And that's the full app. Backend ingestion, vector search, and a clean front end that ties it all together. Now let's talk about the issues I've ran into while building this project. On the front end side, I decided to rely on Gemini to help with the UI, mostly because design is not my strong suit. Earlier in the video, I mentioned how RAG can help reduce hallucinations, and yeah, I became a victim of that. It turned out that Gemini was referencing version 3 of AI SDK, while I was actually using version 6. ChatGPT and Claude were also a few versions behind, which meant a lot of suggestions just didn't work. So in the end, I stopped relying on AI and built most of the front end myself. Another issue I ran into was with my OpenAI API key. When I tried to get the chatbot working, I kept getting an error saying that my API key didn't exist, along with a link telling me to generate one. The funny part was that the link just took me to a page showing my key already there. To fix it, I just created a new API key and used that instead. My guess is that I created the original key before adding any credit to my account, but honestly, I'm not 100% sure. The last issue was one that made me feel especially dumb once I figured it out. I assumed that send message was sending a message with a content field, but in reality, it creates a message object with parts. My backend was reading the wrong property, and once I fixed that, everything started working. Now let me show you the actual RAG chatbot. As you can see, I still haven't decided on a name yet, but let's continue anyways. On the left side, you can upload a PDF, so let's do that. Once the document is ingested and chunked, we can start asking questions. Here, I'm uploading a short story that my brother wrote, so let's ask it a couple questions like what the setting is and who the characters are. As you can see, the chatbot was able to answer based on the context provided. What's cool about this is that I can turn this into a personal chatbot just by creating different Pinecone indexes and uploading different files. It could be health related, education focused, or basically anything. All I need to do is just change the index the chatbot is pointing to. And that's the project. If I made a mistake or there's something I could have done better, let me know in the comments. Thanks for watching.